Hi guys, welcome to our channel of Sciences and Mathematics. Today we are going to look at a concept in electrochemistry, and that is the concept of a redox reaction. Now there are some reactions that we encounter maybe during our studies which involve the concept of oxidation and reduction. Now we're going to see that this concept of oxidation and reduction of course follows some specific rules which entails the oxidation states of different ions of elements. So for today we're going to look at one of the reactions that entails the concept of oxidation and reduction, and we will see how it is going to influence this study of electrochemistry as we move ahead. So for that case, without further ado, I will come you to the topic. So as I've said, we're going to look at the concept of concept in electrochemistry, and this is going to be the concept of redox reactions. So basically this is an introductory topic, and we're going to see how this concept of redox reaction is going to have a role in trying to find out how we can assign different oxidation numbers to ions of elements. And also we're going to see on how different elements can be able to behave whenever they're interacting with other elements of maybe different states. Of course, this is going to give us or to give rise to the concept of reducing and oxidizing agents, which we shall talk about shortly, maybe in through demonstration. So in essence, now this concept of redox stems from the broader topic of electrochemistry, and this basically we say that this electrochemistry we defined it as the study of how chemical reactions produce electrical energy and how in turn electrical energy causes chemical reactions or maybe influences chemical reaction. So for that case, as we have said, this is chemical reactions which are producing electricity and how in turn this electricity is going to initiate the production of chemical reactions. So in an essence, I can be able to or maybe we can be able to illustrate these two particular concepts by having this electrical process that is taking place, and this is a chemical reaction on this other side. So therefore there's a relationship between these two, in a sense that we're trying to see that there's a relationship between chemical reactions and electricity. And in this case, of course, as we can see, this is the concept of change of a form of energy from electrical to chemical and back and forth. So in this case, we are going to see the relationship that exists between electrical and chemical energy, and that basically is going to entail the concept of redox reactions. Now, as we talked from the basic or some of the concept that we have already discussed in some of our videos, the different forms of energy that we have can be able to change from one form to another, or from the law of conservation of energy, we say that energy can be able to be changed from one form to another. And for instance, if I give a demonstration, this is a dry cell that we have that contains, of course, this is a positive, and that is a negative. So suppose we have a conductor that is been arranged that way, and this is a light bulb. So we're going to have this particular cell producing a current that moves through this conductor, and then the effect is that there will be electricity, of course, which is produced, and therefore we shall have a light bulb lighting at this particular point. This is a conductor. So therefore the concept here is that from this cell we have got what we call chemical energy that is being converted to electrical energy through a reaction, which basically is being converted as well to light, which is a form of energy and heat this light bulb. So in an essence, we're going to see that there is an interchange between different forms of energy from chemical, electrical, light and heat, which basically stems from the concept of electrochemistry, whereby the chemicals are producing electricity. And in some cases, we're going to see that there is a relationship between this electricity that is produced and chemicals in a process that we are going to discuss later that is known as electrolysis. In this case, if we have an illustration like this, whereby we have this is a battery, and then we have this is a positive, negative, and this particular connectors or maybe conductors are immersed in a solution of maybe like copper sulfate. There's going to be an effect in this particular solution, of course, which we are going to discuss, and also which entails the concept of redox reaction. And this is the process of electrolysis, which now we're going to see the reverse of the effect of electricity on chemicals. Now in this demonstration for the cell, it's the chemicals which are producing electricity, but the electrolysis is going to be the reverse of where the electricity is having an effect on chemicals. Now by definition, the concept of redox reaction can be defined on a redox reaction can be defined as a reaction in which reactants undergo a change in their oxidation states. It's a chemical reaction in which reactants undergo a change in their oxidation states. And similarly, it can be defined as a reaction in which oxidation and reduction takes place simultaneously. Now, this is just an acronym for the name. This is a reduction, and this is oxidation. So therefore, this is just an acronym for the name reduction oxidation, which combines the two in order to form a term redox reaction. So therefore, simply it means that it's an oxidation reduction processes which are taking place simultaneously. And we're going to see that this one happens in what we call chemical cells. This process can happen in what we call chemical cells. Which are basically devices in which chemical energy is converted into electrical energy. And of course, we have given a demonstration using the dry cell that we were using in order to produce the lighting of the light bulb. So therefore, this in essence gives us or opens us for us a window in which we can be able to understand the concept of electrochemistry and the relationship that exists between electrochemistry and the redox reactions. So let's try to look at maybe a practical example, as we maybe have been talking about the hypothetical example of a redox oxidation reaction. We can be able to give a specific example for this kind of a reaction, maybe using some of the elements or ions that we have talked about. Now, for instance, when we have ion, we're going to look at the concept of a reactivity series for metals, and this is going to give us a clue on how different metal ions can be able to react with others. Now in this case, there's a range of metal ions which can be able to maybe form ions in solutions of other ions. while they make those solutions or those metals in solution forms to become solids. So in this case, when we're talking about the concept of redox reaction, which basically means if I put a metal ion, this is solution of metal X, which implies basically these are ions of that particular solution X, and then I put, this is metal Y. There's going to be a reaction in a way that these two different metals are going to be illustrated using the reactivity series. Now that we have said different metals have different rates of, or maybe the tendency to react in different solutions of specifically different metals, therefore there's going to be a redox reaction whereby maybe this metal is more reactive than this one. This is going to form metal ions, Y is going to form ions, while X, which is in ionic form, is going to be reduced into maybe a metal element, which basically will be a solid, but whose ionic or the oxidation state has been changed. So in this case, this is going to entail also the redox reaction. So therefore, maybe I can give for demonstration purposes just a rough mention of the concept of a reactivity series, so that from there we can be able to discuss on this concept of redox reactions. So I'm going to write a series of metals on the board. So this basically is what I've been referring to as the reactivity series, whereby we have a range of metals from potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, copper, and that is silver. Now in this case we're going to see that I've illustrated this concept of higher and lower. So the metals higher in the reactivity series tend to displace metals which are lower in the reactivity series from their respective ions in solution form. So therefore we call these metals that appear on this part of the reactivity series strong reducing agents, while those ones lower in the reactivity series are referred to as weak reducing agents. So therefore, as we can see from this range, which means if sodium is introduced in or maybe calcium is introduced in a solution of aluminium compound, it is going to displace aluminium from its ions and also form an ionic state of its specific ion. So in this case, we're going to see the concept of reducing and oxidizing agents in a way that oxidizing is going to entail this is a removal of electrons, and this reducing adding of electrons. So therefore there's a specific terms that you have of course used to refer to these metals. These are strong reducing agents because they add electrons to the already present oxidation states of some metal ions. So in this case we can just use that one just by trying to do an illustration using iron. So when iron fillings are added to a solution of copper sulfate, so this is iron fillings added to a solution of copper sulfate, a brown solid which is copper is formed. The color of the solution changes from blue to light green due to the formation of iron 2 ions in the solution. So therefore we're going to have the formation of a brown solid. So there's going to be a formation of a brown solid, and there is going to be a blue to light green. That is, of course, substance that is formed, which is of iron 2 ions in solution form. So we can be able to illustrate this specific kind of a reaction, or maybe try to connect the relationship that we have between here by trying to look at the specific levels of reactivity for those two different ions, one for which is our iron, of course, and this is an aqueous solution solid, which are going to be formed. So in this case, for iron appears at this lower part of the reactivity series, and of course copper appears more lower than iron. So therefore, in solution form, iron is going to displace copper from its compounds. So in terms of this reactivity, iron is more reactive than copper. So therefore, it's going to displace it from its ion. So we can be able to write an ionic equation for this particular kind of a reaction, whereby we have iron reacting with the copper ions to form iron plus copper. So this kind of a reaction is what we call a redox reaction, whereby there's removal of electrons from iron, which of course is losing 2 electrons, and there's gaining of 2 electrons by copper, which of course is gaining 2 electrons from iron. So therefore we can be able to write that particular equation like that, and we can be able to illustrate individual ionic equations using the two concepts that we have talked about, maybe by trying to write this one. So for iron, it's going to undergo oxidation, whereby it's going to form iron 2 ions plus 2 electrons, like that. It's going to lose 2 electrons. Now for copper is going to gain 2 electrons to form copper. So this is solid, this is aqueous, going to form a solid. So these two specific ions, those two specific reactions are known as ionic equations, and there's a change of oxidation number for ion from 0. And for an element or a compound, we're going to see there are different oxidation states, but for this I can just mention that the ionic number, the oxidation number for ion in this state is 0. It has changed to +2, so there's an increase in ionic oxidation state for ion, where there's a reduction. It has changed from +2 to 0. So therefore we're going to see that the first reaction is what we call oxidation, where the second reaction is what we call a reduction reaction. So whenever these reactions are taking place, there's going to be what we call a potential difference, which is going to be experienced in this particular case. So this is going to connect for us the relationship between chemical reactions and electricity, in a sense that when one element is trying to displace another one from its ionic form, there's going to be what we call a potential difference. So in a redox reaction, the energy that is released due to the movement of charged particles gives rise to what we call a potential difference, and this is going to give us the relationship between electricity and chemicals, and therefore this is what gives rise to the concept of electrochemistry. I hope that we have understood the concept of a reduction oxidation reaction using these specific demonstrations that we have done on the board. So finally, I'm going to give an acronym that we can be able to use in remembering the concept of a redox reaction whenever you come across it. So this is the concept of the acronym for the oil rig, whereby oxidation is loss of electrons while reduction is gain of electrons. So basically, when we try to just use that concept of electron, we're going to understand the concept of electrochemistry insofar as the redox oxidation reactions are concerned. So I hope maybe we're going to use this particular video in trying to advance other topics that we have already discussed, or the one that we're going to discuss insofar as electrochemistry is concerned. So that is it for today, guys. Bye, God bless.